One source of examples that we're going to use a lot in this class comes from modular arithmetic. You probably have seen and worked with modular arithmetic in one of your previous classes, but I'm gonna introduce it in this video, and we are going to practice using it a little bit. And the way to introduce the idea is in example 1. So let's look at the set Z7, integers mod 7. And they are the numbers 0, 1, 2, 3, 4, 5, and 6. So you can think about those as all available remainders when you divide a number by 7. Your available remainders are 0, 1, 2, 3, 4, 5, and 6. Now we are going to introduce or interpret these numbers right now as days of the week. So imagine these numbers are standing for the days of the week, starting with Monday. So 0 represents Monday, 1 represents Tuesday, 2 represents Wednesday, 3 represents Thursday. I'm going to use R for that because we already used T. 4 represents Friday, 5 represents Saturday, and 6 represents Sunday. Okay, so there we are. Now let's look at the 3 computations in parts A, B, and C, and let's compute them and interpret them in terms of the days of the week. So what is 2 plus 6 mod 7? So imagine we are starting on Wednesday because that is 2, and we are adding 6 days to it. Where are we? So Wednesday, Thursday, Friday, Saturday, Sunday, Monday, Tuesday. We should be getting Tuesday when we are doing this, and in fact we will. So 8, that's 2 plus 6 in normal arithmetic, mod 7 is equal to Tuesday, which is 1. So that is Tuesday. It represents Tuesday. And the way you can also think about this is, so 2 plus 6 is 8 in normal integer addition, but 8 doesn't really exist in our set right here because so let's divide by 7 and see what the remainder is. If we take 8 and we divide by 7, we have 1 left over. So 8 is equal to 7 plus 1. And that remainder right here is the result of our addition problem mod 7. Let's look at 3 plus 12 mod 7. So 3 plus 12, that is 15 mod 7. And again, let's first do the division in this case. 15 divided by 7, well, that would be 14 plus 1. The remainder again is 1, so 1 is the outcome of this problem as well. So it also represents Tuesday. Let's look at 5 plus 14 mod 7. So 5 plus 14, that is 19 mod 7. And what is that? Well, 19, that is 14 plus 5. So the outcome, the result is 5, and going back to our list up here, 5 is Saturday. So this represents Saturday. So that's an example of modular arithmetic. In this case, we are dividing by 7 because we really only care about what day of the week are we. We don't care about a date or anything like that. Other examples of modular arithmetic could be clock arithmetic. So we have 12 hours on our clock, and then we start over. So if you use military time or 24-hour time, when we are talking about 1500 hours, that is really 3 p.m. So we only care about division by 12 and the remainder. that we have. But we could do this for any integer. And so looking at the definition, if we have integers a and n with n greater than 0, then we define a mod n equal to r as the remainder. R is the remainder when a is divided by n according to the division algorithm. So a mod n will always be a number between, what do you think? The smallest it could be is 0, and the biggest that it could be is n, not quite, it's n minus 1, because n mod n is 0 again. So these are our remainders right here. And we already looked at, so we can maybe just to make this really, really clear and connection with the division algorithm, if you're looking at, if you're looking at 8 mod 7, our example from above, I already wrote it as 7 plus 1, but let's write it as 7 times 1 plus 1. And this one right here, that is q, and this one right here, that is our remainder r. So this tells us that 8 mod 7 is equal to 1. And one more example, let's look at 19 mod 7 from above. So there we have 7 times 2 plus 5. So we have is equal to 19. And again, we have our quotient was 2 and our remainder was r, and we don't care about the quotient at all. All we care about is that 19 mod 7 is equal to 5. So the remainder after division by 7. So this is the remainder after division by 7.